A warm welcome to everybody. This is Arshad Mohammed presenting machine learning concept in smart water purifier and dispenser for averting spread of infections. In this presentation, I am going to discuss about abstract, introduction, literature review, working methodology, conclusion and references. So the pandemic situation which is presently prevailed now has made us to learn about social distancing and more importantly hygiene and cleanliness which we are going to observe. And so here in especially the regards of a water purifier, okay, purification is one of the kind of process of in impurities are being removed from the water, right? And there is a standardized process for removing that, and that standardized process may not be apt for all the users as the age and their medical condition requires a separate type of water. That has been a prevalent one in the every aspect of the research. And moreover, the dispenser system which is in the purifying system, okay, doesn't give us a touchless fill. Okay, that means we have to touch it and manually we have to operate to get the tumbler fill, right? So these are the problems which are being addressed in the present system. The integration of Internet of Things and the machine learning make the devices a smart device which not only able to get the data but also they can think in a very supervised manner, and they can deliver the required thing for the user. And the same information, I mean the same concept has been deployed in the present water purifier system that decides about the user profile and dispenses the water as per the tumbler size. So the both the things are being incorporated and achieved a desired output. In the literature survey, it has been observed that every researcher has presented a topic that machine learning concept and as well as IoT concept has a very good impact on the water purification and dispensing system. And these are the few literature reviews. Here you can see that AI and as well as the IoT concept will improve the water quality index WQI. While coming to the working methodology, the present water purifier and dispensing system is divided into three major parts, that is 101, 102 and 103. The 101 is nothing but a central imaging system. That central imaging system is further consists of two major components, that is microcontroller 101 and a camera 1OB. Right, so 101B, the camera will capture the user, okay, and based upon the YOLO algorithm, the microcontroller 101A will detect the user age and as well as the gender. Based on the age and the gender, the microcontroller will decide which type of water system, I mean which type of water quality has to be set for the user. And further this imaging system, central imaging system 101, further identifies the tumbler size, and based upon the tumbler size and shape, it will decide how much of quantity of water is to be dispensed. These are the two major contributions from central imaging system. And while 102 is water quality adjusting system that further is interlinked with the microcontroller 101A. So the main concept of this second part, that is 102 water quality adjustment system, okay, it will consist of a filtering unit and a high pressure motor and appropriate relays and valves. This relays, valves and high pressure motor and filtering system together will constitute a water quality adjustment system, and these are being judged based upon the commands from these are being deployed based upon the requirements of particular users that is being detected by the microcontroller 101A. So once the user is identified, their age and gender, water purifying what is the water purifying index that is to be maintained for that particular user, that will be retrieved based upon the outcome of a relevant machine learning algorithm which has been deployed. Based upon that, a concurrent signal will be passed to the water purification system, water quality adjusting system, that is 102. This 102's primary function is to filter out the all the impurities and add minerals, and as well as alkaline the water, and that all what are the parameters that are to be included, that are to be excluded, that is based upon the command signal that is being received from 101A, and that command signal will be based on the outcome of a relevant machine algorithm, right? So once the set quality of the water is prepared and it is being ready for dispense, then a relevant machine learning algorithm, that is YOLO algorithm, will identify the tumbler size and thereby identify the quantity of water which is to be dispensed into it, and based on that command and based upon that outcome of the machine learning algorithm, the walls of the water outlet are being operated such that the water dispensing adjusting system 1013 will act accordingly, right? The microcontroller 101A will coordinate coordinate the components 101B, that is a camera, 102A, that are the different types of cartridges for purifying the water, and 102B is a water high pressure water motor that circulates the water through the candles or the purifying system, and 102 103A is the dispensing unit that will a solenoid, that is nothing but a solenoid that will control the water outlet from the dispensing unit, and based upon the tumbler size that is being judged and that is being kept by a user, right? Water will be dispensed, the water dispensing will be controlled by this 103A, that is nothing but a solenoid. Figure 2 shows the component layout of the machine learning based smart water purifier and dispenser, wherein you can clearly see that the microcontroller has an overall control over the all the components, and it is capable of running parallel machine learning algorithms which are capable of identifying uh, the user and the gender, and based upon those outcomes of machine learning algorithms, and the purification system will have a water filter 102, which may be a carbon graphite or reverse osmosis mineral copper alkaline composite types. Different types of cartridges will be placed arrayed one side by side, and all are controlled by the levers, okay, relays. If based upon the requirement, one or two or more cartridges will be placed in series such that water will flow through those candles only and get the required quality index. So once the water is purified and gone through the purification system, the dispensing system, which consists of a solenoid, okay, that solenoid operation is based upon, again based upon the size of the tumbler which a user is holding, based on the central imaging systems capturing system, okay, which captures the tumbler size and executes relevant machine learning algorithm on identifying the tumbler size and quantity of water is to be dispensed. The quantity of water in terms of solenoid operation time will be converted, and the time of operation will be determined. Based upon the time of operation, the solenoid will dispense the the solenoid will be operated, and that in that particular operation time the water will be dispensed. So in the conclusion, it is to be understood by everyone that this smart water purifier and dispensing system will identify the user first, the user age and as well as their gender, and based upon their age and gender, it will define what type of water quality index has to be maintained, and based upon that, okay, the water quality adjustment system, that is 102, which is comprising of a purification system, that will decide which type of water has to be generated, and for that a different type of a flow control will be there, which will regulate the water flow through different cartridges. Once the different cartridges align themselves with the help of a water flow regulator, the water will flow through only those cartridges and get the desired water quality index. Okay, and here the desired, once the desired quality index is obtained, again the microcontroller 101 executes a relevant machine algorithm to determine the size and shape and thereby the quantity of water required to fill that tumbler, and based upon the quantity of water to be dispensed, again a relevant machine learning algorithm is again deployed to convert such a time to convert the time required to calculate the time required to fill the tumbler. Once it has been identified, the microcontroller further identifies the time, and it regulates the valve, and thereby it dispenses the required water. So these are the few references which you can go through it. Thank you very much, sir.